Hello everyone, this is Firdous Ahmed Mir as we were solving questions related to the chemical kinetics that has been asked in JEE Advanced. And today I have chosen a new question with a different concept. So it has been asked in 2019 JEE Advanced. So we will see the concepts underneath this question and we'll try to understand them. So the question is the decomposition reaction twice N2O5 gives twice N2O4 plus O2 gas. All right, it started in a closed cylinder under isothermal and isochoric conditions. At an initial pressure of 1 atm after Y into 10 power 3 seconds, the pressure inside the cylinder is found to be 1.45 atm. If the rate constant of the reaction is 5 into 10 power minus 4 second inverse, assuming ideal gas behavior, the value of Y is. So let me change. All right. It is mentioned here, like the initial pressure is 1 atm. I will be writing initial pressure as P naught. It is 1 atm. And the time given here is Y into 10 power 3 seconds. All right. And the total pressure inside the cylinder is given here. That will, I will write PT is 1.45 atm. All right. So if the rate constant is given as rate constant, I will see K equal to 5 into 10 power minus 4 second inverse. That is given here. Assuming ideal gas behavior, the value of Y is. So here you can see by looking upon the rate constant, it's given here, the units are in second inverse. That means it's the first order reaction. We can conclude from by seeing the rate constant unit is, we can conclude this reaction is first order reaction. That we will keep in our mind. So, but here the reactant species involved here has stoichiometric coefficient 2. That means if it was a simple reaction, not an complex reaction, it was an elementary reaction by somehow. So the rate constant, we simply write rate constant equal to K into the concentration of the reactant raised to power the stoichiometric coefficient. Here it will have become, it would have become 2. It looks like it's a second order reaction from here. But order of the reaction is experimental, so we can't actually deduce the order of the reaction by looking upon the stoichiometric coefficients. So it's not correct. That means it's a complex reaction. It's not a simple reaction. In our previous video, I told about the when we have complex reaction is how we calculate the order of the reaction. We usually use two approximations. One was equilibrium approximation and the another one was steady state approximation. So if I will write this reaction here, it's twice N2O5 gas upon heating N2O4 gas plus O2 gas. It is mentioned here. So at time t equal to 0, the initial pressure, that is P naught, it is mentioned, it is 1 atm. At that time, the pressure of the product molecules here would have been 0. So I wrote here nothing. So after time t equal to t, you can see here the pressure after time t would have been P naught minus 2P. It would have been 2P. It would have been P. So what got consumed here got produced. So the total pressure for this reaction, that is PT, would have been P naught minus 2P plus 2P plus P. This is the entire thing here. What got consumed and what got produced here. So it's the total pressure. So upon solving, we will get here PT equal to P naught plus P. Upon calculating this P, because this P is here, which we have to deduce in order to find the value of Y. So that means I will write here P will be equal to PT minus P naught. That is P naught is 1 ATM and PT is 1.45 ATM. That means P naught P will be 0.45 ATM. All right. But after time t, the total pressure, not actually the total pressure, the pressure remained on the reactant side after time t will be P naught minus 2P. That is P naught is 1 ATM minus 2 into P we got here, that is 0.45 ATM, and we will get 1 ATM minus 0.9 approximately, it will become 0.1 ATM. This is pressure after time t, that is P naught minus 2P. Now we can apply the simple rate law, that is for the first order reaction, that is Kt equal to ln of P naught by pressure at time t. It is simple. Usually we write rate constant in terms of concentration of the reactants, but here it was given as the pressure, so we can just like replace the concentration terms by pressure terms. So, but here, if we will write the rate law, for this rate law is like if I will write the reaction A gives B plus C. This rate law is applicable for this, but we have two in stoichiometry. That means for that case, the rate law will get changed here. It will become twice Kt equal to ln of P naught minus Pt. If you want to like how did we got this 2 in our rate law, we can I can make you understand in next video, like if you want to know about this, how did this 2 came in our rate expression. So upon solving, I will write here 2 Kt equal to ln, it's a natural law converting it, P naught is the initial pressure, that is log of initial pressure, that is 1 upon pressure after time t we got here, that was 0.1 atm. ATM in numerator and denominator will get cancelled out. It will be as 10 here. So using eraser, so upon solving this, I can write 2 times K is given here. K is given here 5 into 10 power minus 4, 5 into 10 power minus 4 second inverse into T is also given, that is Y into 10 power 3 seconds, all right, equal to 2.303. It was 0.1, it will become in numerator 10, log 10 is 1, so we will get 2.303. All right, upon solving this, I will get second and second inverse will get cancelled out. Here we will get 10 power minus 1. 10 power minus 1 we will get here. So upon solving, it's 10 power 2 into 10, 2 into 5 is 10. That is 10 power minus 3, and we will get simply y equal to 2.303. That's the solution for this question. But we have to keep one thing in our mind, that rate law got here changed. We usually write this, but this 2 came because if I will write the rate of disappearance for this reaction, it will be minus 1 upon 2 dn 205 upon dt. dn 205 upon dt will be equal to k into, as it was first order, n2O5, this will be. Upon solving this, upon integrating this, we will get this rate law or the rate expression for this question, and which was the actual need. So actually we got this answer, that is 2.303. As it was the complex reaction, for complex reaction we can't directly tell the order by using the stoichiometry. We usually do two approximations. One is a steady state approximation, and the another approximation is equilibrium approximation. For that, the particular need is we should have given with fast equilibrium. And that's all about this. So I hope you will like this video, and thank you so much.